Magai people. See you at 8. That's funny.
Hello guys and welcome to Web3 Innovators on NFT. This channel provides you with information about cryptos and NFTs and keeps you up to date on the exciting Web3 movement. On Web3 Innovators, we aim to interview successful Web3 founders within the space, hear their success stories, and hopefully by doing so, we aim to influence and educate our subscribers about this emerging space. Today, guys, we have a very special guest. I would like to welcome Medha Parlikar. She is the co-founder and CTO of CasperLabs, who are the creators of the Casper Network. If you don't know what Casper is a proof-of-stake blockchain built based on the Casper CBC specification. Medha, it's a pleasure to have you today. Please tell us a little bit about your background and some of the things that you've done in your career to get to where you are right now.
Hey, Amir, I'm really glad to be here on this interview with you. Yeah, I started working with computers when I was really young. My dad he believed completely in the technology revolution and made sure that I was exposed to it. So I started building, computers, classically, like the good old story of building them in the basement. I was working with my dad to build computers in the basement when I was very young. And then I started working, with computers in a formal way in the early 90s. At the dawn of the internet, right, when the internet was just taking off. And I worked in large companies like Avalara, Adobe, MP3.com, and Omniture, in fintech and web analytics and content and delivery systems. And I love building high-functioning teams, and I love inspiring them to deliver solutions that solve customer problems, right? So I'm very, very much focused on thinking about software as a product. And, I've been able to bring that experience to me when I built Casper. It's really cool.
That's awesome. That's awesome. Before we jump on the Casper subject and you explaining what Casper is, can you tell the audience what is blockchain technology and why it's so important?
Yeah, I think the big thing to first kind of clarify out there is, crypto is a blockchain. Crypto is the first use case of blockchain. And blockchain technology, particularly public blockchain technology, really infuses trust into workflows, particularly where workflows where you're transforming data and that data has a life cycle. It's very logical, right? Like you have a piece of data and it goes through these life cycles. And when you record all that using blockchain technology, you can get guarantees around, the immutability of that data. And that's basically everything in business, if you think about it, right? Business is all about workflows. And for right now, we're focusing on data. When that's trusted, it makes processes faster and easier for businesses. It's also really great for standardizing interfaces and creating a trusted data source within data organizations. So that's really been our focus. We think there's fantastic opportunities over the next 10 to 20 years where you will start seeing collaboration happen between competitors. And that's really when the magic of blockchain technology gets unlocked. But I think we're really early in the adoption cycle still.
Mm-hmm. Yeah, I completely agree with you. And I see blockchain as a revolutionary piece of tech. And it's never happened like in the human history to, for example, the creation of Bitcoin, how decentralized it is, and it hasn't got any owners. It is mind blowing when you look at it on that perspective. So what made you, so first of all, what is Casper and what made you build Casper?
Yeah, so Casper is a public, decentralized, permissionless blockchain protocol. There's a public network known as the Casper Network. There will be several implementations of Casper, several instances of a Casper-type network. And it is a technology that is purpose-built for enterprise, right? So we actually built a protocol that we would use in our day-to-day work. It simply, the other blockchains just didn't resonate with me in terms of their feature set, in terms of what I needed to build product for real customer usage, right? For real enterprise usage. There were core capabilities that I would need as a decision maker. And so when I didn't see them in the marketplace, we decided to go and build those capabilities into the blockchain that we were building. And it was very incremental, right? Like we started off when we built the VM, we focused really on WebAssembly. At the time, WebAssembly was an emerging technology. It made a lot of sense to us. And we implemented a new VM using WebAssembly. And then later on, we added really powerful accounts because security requirements in the enterprise are very different, right? We also implemented granular data sharing that's very, very permissioned. That's another core piece of the infrastructure in Casper. And then finally, we upgraded an on-chain package manager and upgradable smart contracts because, again, not having upgradable smart contracts just didn't resonate with the engineering team or with me. So we went ahead and just built it. And so, CasperLabs is a professional services company. Really, from the very beginning when we founded CasperLabs, it was with the express intent of supporting businesses in adopting blockchain technology because we saw this is the way technology has always been adopted in the enterprise. It's through a professional services arm that educates, supports, and even implements and, in the rollout of tech in enterprises. So we, from day one, it was very purpose-built.
Mm-hmm. And there's actually a use case for enterprise. At the moment, there's a lot of blockchains that are not suitable for a lot of enterprises at the moment. So you guys are trying to build that blockchain that is very, very suitable for them, for what they want to do with their work.
Yeah, right? Absolutely. We believe the requirements for enterprise are actually the same as they are for DeFi or entrepreneurial developers, right? If you have any hope of being successful in any venture you build, you're going to need these things. You're going to need to be able to add new features, which is going to involve upgrading smart contracts. You're going to need to be able to support customers, which can speak to key recovery and key delegation. You're going to need to have some controls over who upgrades your on-chain code as your organization grows. And this is where the permissioning comes into play. These are all things that you're going to need at some point if you hope to be successful at all and deliver great service to your customers, right? And you look at Ethereum and you look at the other protocols, and ultimately they had to find a solve for upgradable smart contracts in Ethereum. It's just really, really complicated, and it's a hack, right? Fundamentally, it's a workaround because the platform, the protocol, doesn't provide that host side capability, so it's not easy. There aren't any guarantees, right? It's not observable on chain. These things are important, we feel, right? So the protocol will provide certain guarantees if you upgrade a smart contract. And so, yeah, we built them because I actually believe if you want to be successful using blockchain technology and for end users, these are some things you really need to provide as a good actor, yeah. Right? As a good actor that wants to comply and provide great service to customers.
That's great. That's great. I love what you guys are doing there. You actually fill in a gap in the niche, it's like a niche there. So what's the technology behind Casper then? So you're talking about smart contracts, upgradability. Can you just talk about a little bit, what the technology behind Casper is?
Yeah. So the Casper technology all centers around the Casper node, right? And this can also be called an Ethereum Geth, right? The Go Ethereum client, right? This is the Casper client called the Casper node. It's the underlying software that when you put 3 or 4 computers running the Casper node software and it's configured properly, then you get a blockchain network, right? That's the core, that's the foundation of the Casper technology. And then there's other things that snap onto Casper, right? This Casper blockchain technology is going to be the smart contracts. It's going to be wallet technology. It's going to be, business intelligence technology, which we call our event store technology or SSE sidecar. It's also hybrid networks and bridging technology. This is another piece of infrastructure that snaps onto the Casper core back end, right? That enables people to interact and work with the network. So when you think of Casper, it's actually this entire ecosystem. And you hear this term of ecosystem a lot in blockchains, right? Because the HTTP protocol that powers the internet by itself is not usable, right? For many, many years, you had the internet, right? But you couldn't really use the internet, right? When DARPA was using it or when the university institutions were using it to send messages to each other, it's very hard to use, right? And in order for that technology to go mainstream, you really had to introduce, the browser technology. And the browser technology made it easier to use. And then you had additional technology, which we now call Web 2. But this is where you had dynamic web pages where it wasn't just reading information, but you were interacting with it, right? It was this two-way interaction, right? And so I feel that, wallet technology is going to be really seminal in the adoption of blockchain to make it a lot easier. Casper's building some really interesting features with 2.0 that will also make, the user experience for end users really easy with blockchain. And I think that's really critical. Without this tech, user adoption is going to be really hard. With MetaMask right now and Ethereum transactions, for the most part, if you want to sign a transaction, you have to pay for it. There isn't any way around that. There's absolutely no way for me to sign a transaction on Ethereum and have some sovereignty without either my wallet being funded to then pay for it directly, right? If I'm custodying my keys, or I have to acquire Ether in order to pay for gas fees. And so simplifying that entire process, I think, is going to be really important to allow users to have sovereignty in signing their transactions, but having somebody else pay for it, right? And that's one of the core value propositions of Casper 2.0.
That's great. I was actually going to get to Casper 2.0 at the end of the interview, but I'm just going to go back a little bit, and I'm going to start with the sector that Casper is trying to solve. Obviously, you mentioned the enterprise. So where do you think Casper can be the biggest problem solver, to have the biggest advantage? What sector can Casper do that in?
This is a really good question. I think it really depends on the adoption curve for blockchain. I think it depends a lot on the regulatory framework, the regulatory environments where the companies are positioned, right? So in some jurisdictions, you have a much more open regulated regulatory environment where you can take advantage of fintech solutions, right? And so some of the deals that we've signed are actually fintech solutions where we're now building core financial banking infrastructure using the blockchain. But this is because the regulatory environment in those jurisdictions is very favorable to that, right? So this is a place where I think we have a fantastic opportunity. It really depends. It's not the answer you wanted to hear, but it really depends. We're seeing a lot of adoption, obviously, in blockchain-first companies around NFT marketplaces where there's track and trace, right? Metacask is doing track and trace and a marketplace for whiskey casks. IPWE is doing it for patents. We talk about these two projects all the time, but we have other projects that are wanting to follow suit. We see a lot of interest around KYC solutions. So, basically being able to do self-sovereign identity is very interesting to a lot of enterprises. And we're hearing from a lot of enterprises that they're actually interested in public infrastructure, which is music to our ears, right? They're not wanting to necessarily spin up private networks. Some of them do, but a lot of them are interested in the public infrastructure and really leveraging the public infrastructure, which I think is just a terrific shift from what we've seen before, where enterprises were shying away from public infrastructure, right? So they're leaning into it now, particularly when we give them all the features that Casper offers. They're like, well, this is great. You're giving us some guarantees and some, proof points around the fact that we can upgrade our contracts, that we can retain some control here, that we can be, compliant with regulatory bodies and government institutions and support our customers. So it's really cool to see. Yeah.
It seems like there's a demand for the enterprise use, which is very interesting. Can you tell us a little bit about some of the partnerships that you guys already have with some of these enterprise companies that you just mentioned?
Yeah, I can talk about some of the ones that are public knowledge, right? So the government of Telangana in India wants to implement an open permission blockchain for their use to speed up the adoption of blockchain technology in Telangana. They're actually looking at a very exciting use case for public contracts in Telangana. So that's super exciting. The idea is to do invoice factoring. And to use the blockchain technology for that. So we're building that out for them right now. And that's extremely cool because it provides immediate benefit for public work contractors in Telangana. So that's really cool. It's a publicly known use case. We've also partnered with IBM. We're one of the only blockchains, if not the only public blockchain that IBM has explicitly partnered with in terms of building out this hyper ledger bridge, right? So assets that are secured using Hyperledger, a private Hyperledger instance, they can now be bridged over to Casper. We will have a production solution for that here coming up in September. And with that production grade solution, the idea is that you can now get liquidity, right, off of these by bridging these assets over to Casper using a stablecoin. So these are real asset-backed stablecoins we're talking about here, right? So you just imagine if a very large bank who has hundreds of $millions in assets that they can prove, right, that they prove that they have these assets using a Hyperledger instance, and it's highly regulated, and you have some guarantees around it. Now you can bridge those assets over to Casper, basically burn them, right? You lock those assets up in the bridge, and then you mint them on Casper as a asset-backed stablecoin. You can definitely get some guarantees around really, like having some real guarantees around these stablecoins on the public network, and this is extremely interesting, right, for enterprises to business banks, right? Real fintech. We call it CFI, centrally controlled finance.
Yeah.
So that's really really interesting as well.
Okay, that's awesome. What's your opinion on NFTs then, and the future of this technology? Do you think these enterprises are going to use the NFT technology? What's your general opinion on NFTs?
Yeah, lots of really exciting use cases around NFTs. Like I have always said that NFTs are how you represent the world around us. Right? Like, your phone is a non-fungible asset, right? You cannot I can't break this up into 1,000 pieces and maintain the value of it. So it is non-fungible. And so our entire world is surrounded by it's made up of non-fungible assets, right? You can't break them up. They're not fungible. But you do want, for a lot of these assets, you want to be able to track and trace them. You want to have some guarantees around them. You want to be able to certify them. There's all of these use cases. There's all of these workflows around this phone, right? It has a unique IMEI number, right? It's tracked. It's got geolocation. There's all kinds of really interesting things that you can do that you need to track workflows. Remember, I said back again, blockchain is about tracking workflows in the enterprise, right? So even unique items that are ascribed some value, it could be worth $100, it could be worth $1, but it has a life cycle, it has a workflow. So being able to track these unique things in the enterprise with workflows, with blockchain is a real natural thing, right? It's very obvious. And I think the enterprise space has really been overlooked in Web3, right? We focused a lot on this very anarchist type of look at it. And there's a space for that, right? There's definitely a space for that. But there's also a space for, when we talk about mass adoption will happen by the enterprise. That's how mass adoption of the internet happened. That's how mass adoption of blockchain is going to happen. It's going to happen via the enterprise, right? And there's this massive white space because all the enterprise blockchains are private. And so there's this huge white space for Casper to have a public enterprise blockchain, right? Where a lot of the information is already public knowledge, or there's benefits to making it secured and public knowledge, right? And so it becomes extremely interesting when you start laying out these use cases for enterprise using a public blockchain.
That's awesome. That's awesome. So how will Casper influence the adoption of NFTs, do you reckon, within the space?
Well, definitely by ensuring that enterprises can adopt the technology, by supporting them, providing really interesting use cases and features with SEP 78, right, our new NFT standard. This new NFT standard basically allows for, how do I describe it, modalities, right? And this is a completely innovative concept with contracts on the blockchain, right? Remember I told you that Casper has an on-chain package manager. And so, what does that mean when you have an on-chain package manager? Well, what it means is you can install contracts, right? You don't just push the contract onto the blockchain, right? You actually install it. And it's a slight difference because when you install a CEP 78, you can configure it. And this is much, much more like traditional software, right? Casper contracts function much, much more like traditional non-blockchain software. And so what does that mean when you say you configure it? Well, when you perform the transaction to set up SEP 78 on the Casper blockchain, you can define what kind of modalities it has. What is the mode in which this CEP 78 contract is going to function? Is it going to allow for transferable tokens or not? Is it going to allow for mutable metadata or not? Does it support digital content or a physical asset? Who has the authority to mint? Is it centrally controlled or is it decentralized? Meaning, can anyone mint? Are you going to assign unique IDs to each of your NFTs, or do you want the contract to assign those IDs? So there's modalities, right? If you're doing a decentralized minting of NFTs, then you obviously want the NFT contract to specify the next logical number for the NFT. Versus if it's administrator centralized, then the administrator will have their own logic by which an NFT ID is assigned. And so the beautiful thing about this is it's all no code, right? You don't need to write Rust code to configure your contract. You can just specify it at the command line. So last week we did a demonstration of using the Python SDK with a no code option where you take, if you choose to trust CasperLabs, you can take the WASM that we give you, and you can use the Python SDK to go ahead and start creating NFT contracts, and you can mint them. And then you can install the contract, you can mint NFTs, and then you can perform functions on those NFTs using the Python SDK, and you don't have to work with any Rust, right? And so this is the pattern we're going to follow with all of our future contracts. We're going to do the same thing for fungible tokens. We're going to do the same thing for DAOs. So if you want to build the DAO, you don't have to understand all of the intricacies of the DAO. You can just configure your DAO and deploy it to Casper, and now you've got a functioning DAO contract on Casper. And this is unique to Casper contracts. And as we upgrade these contracts, you can upgrade your contracts, and we'll provide the upgrade capability, the upgrade WASM, to allow you to upgrade your contracts from version 1.0 to 1.1, right? So these are the benefits of working with SEP 78, and you won't get this on Ethereum, right? If you have a 721 contract, you're basically stuck with that. You're not going to get the benefit of newer features. Even if the Ethereum community comes up with newer features, you really can't take advantage of those because you're locked into 721, right? That's basically all your contract will ever do. And so being able to learn and evolve and develop your software over time is really how all the software that's in the world has ever been built, right? Any software you use has been built incrementally. The startup owner's manual tells you to iterate rapidly. If blockchain doesn't do that, it can't support the needs of startups, right? So fundamental to be able to do this technology in order to have anybody adopt it. That's my opinion.
Seems like you guys have researched really, really well to come up with these solutions, and you have put a lot of hard work in to understanding the space and what the space needs, which is really good. And funnily enough, you actually mentioned Ethereum. I was going to ask you this. So Ethereum, I'm sure you heard from the news that it's going to merge with the Beacon chain, and it's going to turn into a proof-of-stake blockchain, right? And they are calling that Ethereum 2.0. Some people say that Casper is Ethereum 3.0. Can you tell us why they say Casper is Ethereum 3.0? What's the reason for that?
Yeah, so if you look at the full Ethereum roadmap, right, Ethereum 3.0 has two big ambitions. And honestly, like full disclosure, maybe I've not read up on all the documentation and the news that's coming out of ETH. I know that the Beacon chain has rounds, it has leaders, it has eras, it has all of the hallmarks of Casper, right, of a proof of stake fork choice rule type of consensus protocol. But what's not clear to me is the liveness strategy, right? The liveness strategy in Highway was really, really hard for us to nail. And that made Casper pure proof of stake, right? So it's not clear to me if the Beacon chain is pure proof of stake or if it's Casper friendly finality gadget, which still uses proof of work with a lower hash rate, right? So what's not clear to me is what is the liveness strategy for the Beacon chain, right? Because as far as I know, the only provably live implementation of Casper is the Highway protocol. I've not seen research like the Casper protocol that I saw has a vulnerability that was, brought to light by the CBC Casper research team in Ethereum. So number one, I don't know that ETH 2.0 is pure proof of stake because I don't know if it's friendly finality gadget and if there is still proof of work for the liveness strategy, because proof of work is provably live, it's statistically safe. So if Vitalik wants to combine proof of work and proof of stake in the Beacon chain, he would use proof of work with a lower hash rate to propose blocks and then Casper to finalize it, right? So then you get the best of both. And he said that he's wanted to do that. So that's the first thing, that it's not clear to me, right? I'm going to talk about it as if that is the strategy for ETH 2.0. So that's what Ethereum 2.0 is. It still uses the EVM, right? Ethereum 3.0, the bold goal is to be pure proof of stake, where there is no proof of work at all, right? And that means moving from the friendly finality gadget to a pure liveness strategy for Casper. And like I said, the only one I'm aware of is Highway Protocol. The second piece of it is eWASM, right? And this is the WebAssembly engine for Solidity. Now, eWASM is still very much in research. As I understand it, eWASM is not part of 2.0, right? It's part of 3.0. That may have changed because, again, I'm not clear where it's landing. But as I understand it, eWASM is still very much in research, right? So Ethereum fully intends to move to a pure CBC Casper implementation with WebAssembly, right? And this is why people in the Casper community believe that Casper is Ethereum 3.0, because we already use WebAssembly and we already have pure CBC Casper.
So you are basically what Ethereum is trying to become?
That is the assertion. That is the belief, yes. And I mean, if you look at the facts, that's what it looks like, right? We don't support Solidity, you know, because Solidity can't compile down to WebAssembly, right? If Solidity can compile down to WebAssembly, and there are initiatives inside the Casper community to work off of the Solang implementation, right? The Solang implementation uses an LLVM, you know, middleware, right, as part of the eWASM initiative that does transpile Solidity into WASM, right? So that is research. That is an initiative in the Casper ecosystem. It's been funded as far as I know. We did an early prototype at Labs. We've since then been focusing on the contracts FFI and really getting that kind of buttoned down. But yeah, it is absolutely possible to transpile Solidity contracts into WASM. But there are vagaries in the EVM, right? There's weird things. The EVM doesn't have Booleans. The EVM does a lot of really strange things that WebAssembly doesn't do, right? And I think these are the things that need to be implemented in eWASM. It's these weird things that there's a lot of workarounds and acrobatics that you do when you are, you know, especially if you've written software the traditional way, and then you look at Ethereum, the EVM, you're like, what? Like, what do you mean there's no Booleans? Like, why are Booleans so expensive in EVM, right? Things like that. There's some weird things that exist in the EVM that regular developers just kind of scratch their heads at if you've never worked with the EVM.
And something about Casper that I've found out is that devs can actually write in their own programming languages as well, which is not something that you see in the space right now with blockchains, right? Can you explain a little bit on that as well?
You know, the first class support is absolutely, it's Rust and AssemblyScript. Those are the first level support languages. But Casper accepts WASM, right? It accepts WebAssembly. So if you want to compile your contracts onto WebAssembly, and you can submit them to Casper, right? So you can understand what the contracting FFI looks like, and you can go ahead and write your contracts in any language you want, provided you're implementing the semantics of the Casper VM, and the system will run the WebAssembly, right? It's pure WebAssembly. We haven't stripped anything away from WASM, right? We haven't done things in the VM that constrain WASM, right? So you can actually write, if you send WASM to the Casper VM, it will work.
Okay, awesome. And let's move on to Casper 2.0. I think you guys have mentioned that it's going to happen towards the end of the year, that the network's going to upgrade into 2.0. Can you tell us a little bit about the upgrade and its capabilities? And if you can include the Casper NFTs into that as well, that would be great as well, if you could explain what's going to happen with the NFTs.
Yeah, so definitely. So Casper's 2.0 upgrade, we're actually targeting testnet in Q1. We've had some delays because of 1.5. It's really unfortunate, but 1.5 is really important for the network, and we're looking to get that shipped in the next 4 weeks to mainnet. But Casper 2.0 work is underway. And so what's really exciting about this is we will be one of the only protocols out there that will be upgrading consensus within 2 years of launching mainnet, right? We pull this off before March 31st. And the reality is that we already have a working prototype that actually switches between Zug, which is the new protocol, and Highway, which is the old protocol. So every 2 eras, the protocol just switches between the 2 consensus protocols, so that's how we've been benchmarking it. And so this is possible because of Casper's infrastructure, right? This is the architecture of the node. We can drop in any consensus protocol we want. And it's hugely important to be able to continue research and upgradability and to implement new technologies as they come to us, right? And to really take advantage of all of the work that's being done in this space. And this is a really, really big deal, right? That, we expect block times to become a lot faster. We're targeting 4-second block times. We're targeting 250 validators. That is the goal. We've been able to benchmark so far successfully, 4-second blocks. Now, there's some stuff in the VM we need to work through to actually push through and improve throughput. So for that, we're simplifying the serialization that we do in the system and reducing the amount of serialization that we do and streamlining it and normalizing it. So we're hopeful that that's going to speed up throughput of execution, right, the smart contracts. We're also working on what we call the account contract unification. So something that's unique to Casper that is not part of Ethereum either, or many other blockchains, is there's actually 2 execution contexts, right? So accounts in Casper are more than an address. In Ethereum, all you do is you get an address, same as the Bitcoin model. In Casper, accounts actually have storage. So you can run code in your account. You can store things in your account. You can assign associated keys in your account. You can have, recover keys, right? And you can execute this with what we call session code. There's also the contract context, right? So every time you invoke a contract, the call stack starts in session. So every execution starts in your account because that's the account that's signing the transaction. So it starts an account and then you invoke the contract from there. And so what we're going to be doing is unifying these notions. So it'll just be an object in the VM. And the object can be of type account or have of an account or a contract, but they have the same properties. So when you overlap an account and a contract, some really interesting things happen because they basically get the properties of both. And so what can accounts do right now in Casper? Well, they can pay for transactions. They can stake the network. So these 2 things will be given to contracts. So contracts will be able to stake the network, and contracts will be able to pay for transactions. So what does this do? Well, this becomes really, really cool because contracts will be able to pay for the execution of users. So users will be able to sign transactions, but the contract will pay for it. And so what does that do to the UX, like I talked about before, right? It makes the UX a whole hell of a lot easier. Right now, I don't need CSPR to pay for execution. I can interact with the dApp. I can pay a subscription fee the way I've always paid for subscription fees, right? So if I want to get my Apple Music, I'm paying $15 a month or whatever I'm doing, right? If I have this cool dApp, I'll pay $10 a month for a game or whatever, and now I can sign all these transactions, and the game just covers my costs, and it just meters it, right? And then when I've used up my transactions, I may have to upgrade my account to unlimited or upgrade, right? And so this is all doable. This is the way software has always been built. This is the way users expect to interact with their software. Sending them off to an exchange for them to go ahead and get some token doesn't make any sense at all, right? And so this is the way things will work post 2.0 for our contract authors, right? So really, really, that's a super exciting set of smart contracting capabilities. And because they're net new features, right, contract authors will want to upgrade to Casper 2.0. They'll definitely want their contracts. They will be automatically versioned by the host when 2.0 ships. And they'll want to upgrade their contracts to take advantage of these new capabilities because it makes things so much easier for the end user, right? Really, really easy. And then for DeFi protocols, it gets super interesting. If you lock your CSPR, now that contract can stake the network. And so now DeFi protocols will actually get more yield. If you're natively locking Casper up, you can now stake that Casper and contribute to the security of the network, right? Because now contracts will have a main purse.
And what's the TPS going to be like, transactions per second on Casper?
Don't know yet. Don't know yet. Yeah, so block finalization will definitely go down. It will still be execution after consensus, right? So, there is no optimistic execution in Casper. Casper, once a transaction runs, it's finalized. which is a great feature, right? It's very simple, right? You don't have to say, is it done yet? Is it done yet? Is it done yet? Is it final yet? Is it like, you have to do that in Ethereum. And then if your transaction winds up on Uncle, it gets rolled back, and then you have to you have to deal with all of that back and forth, and then you have to do nonce management, right? Like there's no nonces in Casper. You don't have to deal with nonces, right? So all of that is a lot simpler, right? You don't have to deal with any of that overhead. With respect to transactions per second, we have to still benchmark the 2.0 VM, right? So we don't actually know what the size of the blocks are going to be once we make them a lot shorter. We'll have to figure that out, right? And a lot of that is dependent on, transaction size, deploy size, right? And those deploys have to get gossiped across the network, right? So we're still bound by the last mile, right? Like bandwidth, right? Very much. Casper's still bound by bandwidth. So there's going to be some, theoretical limits that we will have to adhere to, right? And some practical limits with Wasami. Yeah.
I've heard that you guys are going to implement sharding as well. Is that correct?
So we're not going to implement sharding yet. Like after 2.0, we're going to see what the throughput is. Our blocks aren't full yet, right? So when we start seeing blocks get full, then we're going to start definitely looking at sharding. Side chains is the first thing we'll look at, right? I think sharding and side chains are two different terms. This was drilled into my head by Ethereum researchers when I worked with Ethereum researchers. They said sharding, composite sharding, is different than side chains. Side chains, having code mobility across side chains is very difficult, right? Because once you're on a side chain, your contract is stuck on that chain. Composite sharding allows you to basically shard the memory space and the storage space within the global state itself, right? So you basically say, I'm going to take this address. Alternatively, you can actually shard the validator and set and potentially say, well, I need a lower threshold of guarantees, so maybe I only need 5 or 7 validators to validate my contract versus all of the other validators, right? And so there's a potential to do some research around that kind of sharding. But it's all very, very theoretical. Casper will take on the challenge of doing side chains, and that's bridge technology. So our first implementation of bridge is going to be a Casper to Casper bridge, right? So that will implement side chains. And then from a Casper to Casper bridge, then we'll look at potentially doing parallel execution. Daniel Kane has already proposed some theoretical, sharding, composite sharding options. So that is something that we are going to look at. He's already got some theory that he's been working on. And then we're also looking at parallelizing, right? So transactions that don't conflict can theoretically run in parallel. And so we have an initial prototype for this. It's something that was prototyped very early on in the project, in fact. But again, blocks aren't full. So once blocks get full, we can talk about that, right?
Fantastic. Casper is very, very exciting to me. It's really, really good. And it can really shift, it can really make some huge changes in the space. And it can lead the way with the technology that it has. So where do you see Web3 going within the next 10 years, especially with Casper? Where do you see Casper going within the next 10 years?
So our goal is to, spur enterprise adoption, right? So I would love to see many household name enterprises using the public Casper protocol, right? And we're going to continue to evolve at least recommend. And we believe the community supports us a lot, but we're definitely going to recommend enhancements and features to the Casper protocol, right? In collaboration with the community that will help spur enterprise adoption, right? And our community is pretty amazing in that they're very much pragmatic, right? They see the value, and they're tightly aligned with us on the value of enterprises bringing this technology to consumers, right? I see enterprises as a core middleman in mass adoption, right? A lot of the technologies we use today are absolutely run by centralized authorities, even if they decentralize content, right? Medium, you still know what Medium is, even though Medium decentralizes the creation of content. We still know what YouTube is, even though YouTube decentralizes the creation of video content and empowers content creators to build content. And even in a decentralized world, people are still going to need to trust somebody, right? They're still going to need to trust somebody to provide a place they can go some way. Even if it's a contract, that's fine, but the contract is going to have people behind the contract, and you're going to want to know who those people are. If you don't know who those people are, then how do you know they're not going to rug pull you someday? How do you know there isn't a back door, right? Like, the average individual is never going to read contract code. Like, they're not going to be able to independently verify if a contract is trusted. They're going to need to trust somebody, right? And we talk about how do you establish trust, right? How do we establish trust today, right? And I just don't see that going away even in 10 years, even in 20 years. I just don't see it going away. And so that's why we are here to enable them, right, to enhance their offering with decentralized principles, right? Self-sovereign identity, self-sovereign medical records. Does it mean you're not going to go to a hospital? No, you're still going to go to a hospital, right? Like, and you want that hospital to support self-sovereign medical records. That's good. The hospital doesn't want to hold on to your medical records. They actually, in the United States, it's a massive risk and a liability. They will happily decentralize that, right? But you're still going to need to work with them, right? So this is the way I see this adoption happening.
And do you think a majority of the world in the next 10 years will start using blockchain technology to send money to each other or whatever? Like, you know, what's your opinion on that? Do you think it can be mass adopted, you know, on a huge scale?
I do think blockchain technology is going to be massively adopted. I don't think there's any argument on the merits of blockchain technology. I think there's massive argument and massive fear around the adoption of cryptocurrency. The two are very different, right? Now, granted, public blockchain infrastructure, particularly proof-of-stake public blockchain infrastructure, needs cryptocurrency. It's like, it's not just cryptocurrency that needs blockchain at this point. With proof-of-stake networks, blockchain security needs cryptocurrency, right? So it's like it's gone both ways now. With proof of work, it doesn't need it. Proof of work doesn't need crypto. It purely provides a basis. I mean, to a certain extent it does, because if the crypto isn't worth anything, nobody's going to invest in the hardware, right? So there is a bit of a dependency there, right? Like, right? If the crypto isn't worth anything, then no miners are not going to support it, even in proof of work, right? But it's definitely more important in proof of stake, right? You get your security, like it or not, from the crypto being backed, right? And being available and having some value. So there is, that is something to consider, right? For public, but blockchain technology is going to stay. Right? And we're positioning ourselves very strongly around blockchain technology and the additional security guarantees you get from public decentralized ledgers. We believe public decentralized ledgers provide an additional layer of security that private blockchain technology simply cannot provide, right? And there is a space for it because there's plenty of public information, right, that needs to be secured, that needs to have some guarantees, that needs to be immutable, right, for the benefit of the consumer. And so that's where we're positioning ourselves.
And the good thing about Casper is that it solves all three trilemmas as well, which is decentralization, security, and scalability. Right?
That's right. That's right. Now, people need to bear in mind, right? Like, when you talk about Visa having 40,000 transactions per second, there is an entire server farm. And this is not a replicated VM. People need to get really, really clear about that, right? 40,000 transactions per second is not possible with the current silicon and bandwidth that exists in the world today. It's not doable. Probably in the future when silicon makes it possible. But right now, if anybody is promising you more than 3,000 transactions per second, it's a total lie. Like, it's a total lie. A single machine, I worked at Avalara, and when I worked at Avalara, and it was 2016 when I worked at Avalara, but a single node's throughput was about 1,500 transactions per second on a single machine for tax transactions, right? That was a single machine. They used a shared database, and they had 20 machines, right? And so when you process a transaction, even in Visa, when you process a transaction, it's each of those machines in that big IP, they're each processing independent transactions in parallel. So the 40,000 transactions are across 4,000 servers. It's not one machine, right? And the blockchain, It's one state machine. And those 100, 200, 300, 10,000 computers process the same transactions. This is a really, really important point when people talk about TPS. And I just laugh and I shake my head when they start, we can process 150. No, you can't, right? And the reason Vitalik says that, he knows, is because there's going to be 1,000 shards, right? That's why he's saying that. He's saying there's going to be 1,000 shards, right? And each of those shards is going to process a certain TPS. And so when he talks about Ethereum 2.0's overall performance being X, he's adding up the transactions across those 1,000 shards, right? That's what he's doing, right? So when people say, oh, yeah, we have a single blockchain with a single shard or a single chain, and it's processing 40,000 transactions, it's a lie. It's just not true, right? It's not doable today. I would definitely give those projects a hairy eyeball.
Yeah, that's it. Medha, thank you for dropping all this knowledge on us today. It's been a very, very good interview. I personally really enjoyed it, and I'm sure the audience can learn a lot from the interview. What advice would you give to the newcomers that are coming to the space? Because the space can be sometimes scary, to when you walk in, you see all the scams happening, What advice would you give them if you were in their position? Yeah,
for sure. So I would say establish trust the way you do today, right? So don't click on a link you don't know about. Don't get involved in a smart contract you don't know about. If you don't know who the people are behind the technology, don't get involved with the technology, right? This entire notion of being completely anonymous, I'm not a huge supporter of it. If you're not willing to put your name and your face out there behind the technology, they haven't done what they need to do to earn your trust, right? And they are asking you to trust them, right? And so making sure that you know who you're getting involved with, doing your due diligence, doing your research. And if you don't understand the tokenomics and you don't understand the technology, don't back it, right? Don't back it. Show up at the community calls, ask hard questions, have an expectation that you're talking to core developers or founders of the project and that they are showing up and answering your questions and are transparent, right? And look at the track record of the project and understand also that crypto's really volatile, right? So don't put your money into it unless you can afford to lose it. And please, please, please do not take on any kind of liability. Do not borrow to invest. This is like basically gambling when you do this. So please, please, please do not do that. Only invest what you can afford to lose.
Very wise words. Thank you very much, Medha. Medha, thank you for coming on today. I really appreciate it. Thank you for your time. And I wish you the best of success.
Thank you.
Of course. And I wish you the best of success at Casper, guys. Casper. And I hope you guys smash it.
Thank you so much. Yeah, and for the community out there, if you ever want to reach out to us, you can find me on Twitter at Parlikar. You can find me on Telegram, same handle. And we are CasperLabs.io and Casper.network. Thank you so much.
Thank you very much. Take care.
You too.
Bye-bye.